For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. If x cubed plus 1 over x cubed equals 970, then what is the numerical value of x minus 2 times x minus 4 times x minus 6 times x minus 8? Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so given this equation, x cubed plus 1 over x cubed equals 970. And also, x is in the set of the real numbers. Then, our goal is to evaluate this expression x minus 2 times x minus 4 times x minus 6 times x minus 8. Alright, so to answer this question, we have x cubed plus 1 over x cubed. This reminds me of this identity. If we have a cubed plus b cubed, this can be factored as a plus b raised to the power of 3 minus 3 times a times b times a plus b. So here a represents x and this b represents 1 over x. So the left hand side of our equation can be factored as follows. We have x plus 1 over x raised to the power of 3 minus 3 times x times 1 over x plus x plus 1 over x. So we can replace the left hand side with its factored form or equivalent form. Alright, now let's focus on this product x times x. We know we have x over 1, so x times 1 over x. This is just gone and must be equal to 1. So this simplifies to x plus 1 over x raised to the power of 3 minus 3 times x plus 1 over x. Now, we can see two similar terms right over here. So as we all know, if we see a lot of similar terms, we need to replace this with another variable. Now let's call this as n. So we can replace x plus 1 over x with the variable n. And if we do that, we get n cubed minus 3n equals 970. Alright, now let's set aside this and let's focus on the equation. Now, to solve for the value of n, take note, x is a real number, so n is also a real number. Alright, now let's equate this to 0. So we have n cubed minus 3n minus 970 equals 0. Now, to solve for the value of n, we need to replace this negative 970 or negative 970 with 1000 minus 30. Because 1000 minus 30, this will give us 970. Now, the question, why 1000 and 30? Why we choose this number? Because 1000, we can rewrite this as 10 cubed. And it corresponds to this n cubed. And this 30, because we have 3 times n, if we factor out 30, we have 3 times 10. Alright, now let's use this condition or this property to answer this question or to solve for the value of n. Now, first, let's distribute this negative sign. So this will give us negative 1000 plus 30. Next, rearrange some terms a little bit. Now, we know 1000 is 10 raised to the power of 3, as I said a while ago. And we can factor n cubed minus 10 cubed. So we can use this identity. If we have a cubed minus b cubed, this can be factored as a minus b multiplied by a squared plus ab plus b squared. Now, a represents n and this b represents 10. So, n cubed minus b cubed, this can be factored as follows. We have n minus 10 multiplied by n squared plus 10n plus 100 or 10 squared. Alright. Now, how about negative 3n plus 30? So we can factor out because 30 is 3 times 10, so we can factor out this 3. And if we do that, we get negative 3 multiplied by n minus 10. Now, the main reason for doing this is we now have a common factor of n minus 10 on these two terms. So we can factor out n minus 10. And if we do that, we get n minus 10, which is our common factor, multiplied by n squared plus 10n plus 100 minus 3. Now, we can combine similar terms. 100 minus 3, this will give us 97. And now it is equal to 0. So we can use the 0 property. Or it simply say that at least one of them must be equal to 0. So we can say that n minus 10 equals to 0, our first case. And the second case is n squared minus 10n plus 97 equals 0. Take note that n here must be an element of a real number. Alright? Now, solve for the value of n. Let's add 10 on both sides. And if we do that, we get that the value of n on the first case must be equal to 10. And 10 is a real number, of course. So this is possible. Now, how about on the second case? Now, this is not factorable. So, to determine if n is a real number, let's use the discriminant of this quadratic equation. And the discriminant is given by this equation, b squared minus 4ac. Now, this a represents the coefficient of n squared, which is 1. This b represents the coefficient of n, which is 10. And this c is the constant term, which is 97. Now, let's replace all of these values. Let's replace this a with 1, this b with 10, and this c with 97. Now, let's simplify. 10 squared, we know this is 100. 4 times 97, this will give us 388. 100 minus 388 must be negative 288. Now, the discriminant is less than 0. It immediately tells us that we don't have a real roots or the real number of n in this equation. So, n here is not a real number. So, we disregard this case. Therefore, the only real value of n must be equal to 10. And we know that n is also equal to x plus 1 over x. So we can say that x plus 1 over x must be equal to 10. Now, what we're going to do is to multiply both sides by x to eliminate the denominator x. And then, let's equate this to 0. So we have a quadratic equation x squared minus 10x plus 1 equals 0. Now, this is very crucial because we can now use the given expression that we want to evaluate. Now, notice, negative 2 plus negative 8, we have negative 10. We have negative 10 right here. Negative 4 plus negative 6, this is also negative 10. So, what we're going to do is to rearrange some factors like this. And let's multiply x minus 2 times x minus 8. If we do that, we get x squared minus 10x plus 16. Now, if we multiply this factor, x minus 4 times x minus 6, we get an answer of x squared minus 10x plus 24. So, we can replace this factor with its equivalent and this factor with its equivalent. Now, we will use the equation or the resulting equation that we did last time. So, x squared minus 10x plus 1 equals 0. Now, what will happen if we subtract 1 on both sides? We get that x squared minus 10x must be equal to negative 1. So, x squared minus 10x right over here, this is just negative 1. Also, this x squared minus 10x is also equal to negative 1. So, our expression trims down to negative 1 plus 16 times negative 1 plus 24. Negative 1 plus 16, this is positive 15. And negative 1 plus 24, this is 23. And 15 times 23, this is very simple. This is just 345. And that is the answer to this question. Therefore, if x cubed plus 1 over x cubed equals 970, then the numerical value of x minus 2 times x minus 4 times x minus 6 times x minus 8 must be 345. And as always, we are done.